Okay, so all that was just our background work to get to question 1. We haven't actually answered question 1 yet. Okay, so question 1 then, what do we need to run and what variables are we running it on? Good, we need an ANOVA because we have 1 independent variable with 3 levels, so treatment with 3 types of treatment, and 1 dependent variable, and what's our dependent variable? The ADHD difference score that we just created. Okay, so how do we do that? Good, analyze general linear model, univariate. What's our dependent variable? Difference score, which should be the last thing in your data set. And I went back and labeled mine, so that's why there was some confusion a minute ago. The label shows up, but if you hover over the label, whatever you typed in the label column, that's usually what shows up. But if you hover over the label, then it gives you the name, like the shorter name of the variable. So ADHD diff comes up. That's my dependent variable. What does fixed factor mean? Independent variable. And what's my independent variable? Treatment. And press OK. Okay, so glance at the little top chart first, just to make sure that it makes sense. Now, for y'all, since y'all didn't set up this study, you wouldn't know if it made sense. But if this were your own study and you knew you had 50 people in each treatment and the numbers come up as 33, then go check your data before you get too excited about the results, because you need to get the data right first. But in this case, this is right. There were 33 in each treatment. Which of these p-values do we look at? Good, the one associated with the independent variable, which is treatment. And so what does this tell us? Yeah, there is a significant difference in ADHD difference scores across the treatments. Okay, so how would you word this? Perfect. In order to test the hypothesis that, and then you're going to cut and paste the hypothesis, right? And you're going to change the future tense. So the hypothesis usually says there will be. But once you have your data, you actually go back and change that in your hypotheses as well as in your results, that there would be. Is that whatever that's called, past something? So in order to test the hypothesis that there would be a difference in ADHD change scores across treatments, then what's the rest of the sentence? An ANOVA was run. Results were significant. Open parentheses, F, and then little subscript. I can write it on here. It will not show the video. Open parentheses, F. That looks like a permanent marker, sorry. And what am I putting in my little subscript? Okay, good. Degrees of freedom. Good. Treatment, comma, error. What's my error degrees of freedom? 96. Equals, and then you put your F value, which is what? Okay. Comma, since it's 0.000. Good. I've got to put less than 0.001. Okay. Are we finished with this question? Okay, good. We're not finished with this question because we don't know where the differences lie. If this came up, if this ANOVA came up as not significant, would we be finished with this question? Yes. But since it's significant, we have to do post hoc because we don't know where the differences are. So how do we do that? Anybody? This is the easy one. No. So same thing we just did. Then hit post hoc. Under factor, it says treatment. Remember, factor means independent variable. Put it over under hit the little arrow and put it under the thing that says post hoc tests for. Scheffé and Tukey will run all pairwise comparison, so either's really fine, but go ahead and hit Shift so we all get the same thing. Press continue and press OK. Okay. So what does this tell us? Okay, good. There's a significant difference in the amount of change in ADHD scores between the medication-only treatment and the combined treatment. And in which one did people change more? Okay, so how do we figure this out? Okay, well, right now, just this line, the only thing that this is telling us about is a comparison of medication to combined. So let's do just that one first. Okay, so this number tells us the difference between the I column, which is whatever's right here, and the J column, whatever's right here. So this took the difference score from the average difference score in the medication group, and what does that score mean? Like higher difference scores are good or bad? They're good, because remember the way we subtracted, higher scores mean more change in a good direction. Okay, so we have the average change score here minus the average change score here, and we get a negative number, which means the change score was higher in which of those groups? The combined. Remember, we're only looking at, this is the medication group, this is the combined group. So we do this number minus that number and get a negative number, which means this one's higher. Okay, so people in which group changed more? The combined group. Good. That every time I get to these charts, like I have to think through and I'll have to write all kind of stuff. Okay, wait, is higher scores better or worse? And then which way did we subtract? And then is it a negative or positive? So you really have to like think carefully so you don't get it reversed. But because this is a negative number, the people in the combined group had a higher score than the people in the medication only. It's significant. So what can we say? Worked better. Yeah, the combined treatment worked better. Yeah. I mean, you have to like say it professionally, but okay. Okay, so we just did this. So we said basically the overall test was significant. The overall ANOVA was significant. Post hoc Scheffé analyses were run and indicated that the combined treatment group, or people in the combined treatment group, changed more in the expected direction than people in the medication only group. And then what data do we have to put to support? So what do they call it? Mean diff, which is the mean difference score, equals, what was it, 11 point, so we'll round off to 2, 4, 5. And what was our P? Less than 0.001. It really doesn't matter if you put negative or positive, because you'll see later we have the same comparison subtracted the other way and it's positive. So it really doesn't matter which way you put it, as long as you tell us in the sentence which group changed more in the expected direction. Does that make sense? Okay. And then we got to check out what else we have that's significant. Okay. All right, so what does this one tell us? Good. So people in the combined treatment changed more in the expected direction than people in the behavioral only treatment. And then same thing, you'll put mean diff equals 10.82, comma P less than 0.001. Now we have two more significant down here. Do these provide us with any additional information? No, because it's the same comparisons we've already reported. Okay. But we do have one other that we haven't reported about, so you want to report on that one. There was not a significant difference in change scores between the medication group and the behavioral group. Mean diff equals, comma, p equals 0.69. Make sense? All right. Where were we on time, Tim? Okay. Okay, look at the next question while I'm uploading this and see what you think. What happened here? The next hypothesis.